This is graphing inequalities. So what we're trying to do is plot some ordered pairs that make the following inequalities true. In fact, we want to plot all of them. So the way we do that is this. Number one, you graph the line. So we have to graph x plus y equals 10. And the quickest way to do that is to use intercepts. Just we need 2 points to make a line. So remember, if we plug in 0 for x and 0 for y, it'll give us our intercepts. So you plug in 0 for x, which makes y equal to 10. And if you plug in 0 for y, that would make x equal to 10. So graphing that, we get that point and that point. 0, 10, and 10, 0. And this allows us to draw the border. My lines never come out, they just don't want to come out nice here. Close enough. Okay. Now we just have to find the point to shade with. Okay? So either we're going to shade this side of the line, or we're going to shade up this side. We got to find out which side is true or false. So that's step 2. Test. Okay? So I'm going to pick the point 0, 0 because it's nice. And we're going to plug it in our inequality. This one. So if you plug in 0 and 0, it will come out true or false. Is 0 greater than 10 or equal to 10? No. That is false, which means this point is false, which means everything over here is false, and everything over here is true. And for me, I like to double test it, so now I'm going to pick a point that's on the true side. I'm going to pick 10, 10. Plug it in again. Is 20 greater than or equal to 10? That is true. So see, everything over here, you pick any point on this side, it will come out true because these are all the solutions to that inequality. So now we are allowed to shade everything over here. It doesn't just stay within our grid, it goes on forever and ever. Everything over there. So the line itself is just a border for the solutions. That's it. Alright, so let's try it again with this one. So first thing is to graph the line, and we can use our slope intercept. So graph first, y equals x minus 2. So that would be y equals 1 over 1 x minus 2. So see, this one is set up as a linear equation for slope-intercept form, and this is a linear equation that we can use y-intercepts for, x and y-intercepts for. You can always solve for y as well and do this method. Alright, so our y-intercept is negative 2, right there. And then we're going to go up 1 over 1, up 1 over 1, and that's our line. So again, that's our border. Here's the thing though, on this. This is not equal. So when it's not equal, you must use a dotted line because it will not actually equal that line. Okay, and in fact, I want a nicer line that goes all the way through it, way over there. And I'm going to come back and make it dotted. Get the idea? So what it means is any point that you plug in here for the equal is not going to actually be true here. For example, the 0, negative 2. If you plug it in, it doesn't equal negative 2. And so negative 2 is not less than negative 2. So we don't actually equal this line, it's just a border. Alright, so now to shade. Change the stroke on that to get rid of it better. There we go. Alright, so now part 2, and that's a test point. And again, I like to pick 0, 0 because it's not on the line. If it is on the line, then you must pick a different point. So we plug it in. Is 0 less than negative 2? No, it is not. That is false. So that means this side is false because there is 0, 0. So everything over here is false, which means everything over here is, you guessed it, true. And we'll double check that. And so I shade this side. And there it is. That's all you're doing. You're graphing the solution sets to each inequality. All right, so let's just double check that this is the true side. So any point over here, let's do something on the x-axis. How about that point right there? That's 1, 2, 3, 4, 5, comma 0. So we're going to plug that in. Is 0 less than 3? Yes, it is. That is true. So everything over here is true. Everything over here is false. We're good to go. So if you feel like you got these. So number 1, graph the line. It gives us a border between the solution set. Number 2 is test to see which side has all the true solutions, and that's the side you want to shade. If it's solid, then it means it's equal. And if it's not equal, that means you have to put a dotted line. So these are your rules right there. If they're not less than or greater than, it's dotted. Less than or equal, greater than equal, it's solid. And the way I kind of remember is that, look, it kind of has a solid line right there. The equal sign is the solid line, which is what it does represent. That equal sign represents the solid line. All right, so give these a shot. I've given you some space to graph them any way you want. So if you want to do some tables or work or whatever, and then put your solutions right here. Okay, hit pause and give them a shot. If you don't know one, skip it. Come back to it later. All right, and these are the answers right here. Remember, the first one is a vertical line because it's just x. It also should be dotted. So the first two should have dotted. The last two are both equal, so they should be solid lines. And on the last one, if you decided to solve for y, to graph it, just make sure when you divide by a negative, you flip the inequality. All right, and that's it. If you also want to see more of a connection, if you kind of look at this one says y is greater. And you notice we shade up from the y. This one says y is less. And if you notice, we're shading down from the y. We're shading down in the y direction. And then this one, after we flip the inequality, because we divided by negative, we get y is less than. And again, we shade down in the y direction. And the first one was x is greater. So if you notice, we shade in the x direction. This is when x is getting greater. It's a nice little connection as well if you want to shade that way, just to double check it. All right, thank you.